Hello level 3s, welcome back to another video. This is going to be a quick video and we are going to talk about the hydrolysis of esters. So as you can remember in the last video we looked at how esters are made, and we either make it with a carboxylic acid and alcohol that we kind of squash together and it makes this O link between them called esters, or we could use an acyl chloride and an alcohol, squash them together and it forms an ester as well. So today we're going to look at the hydrolysis of esters, and hydrolysis is a fancy word that we use to explain the breaking up. So if we could break up an ester, it's called the hydrolysis of an ester. And there's two ways that we can do it. So the first way that we can do it is we can use it with an acid to break up and split up the ester, and what happens with that reaction is the ester just goes back to its original state. So if we have an ester and we break it up, it becomes a carboxylic acid and an alcohol again. But when it's a bit trickier when we use a base, because when we add a base to an ester, it breaks up into a carboxylic acid and an alcohol, but the carboxylic acid, remember, is an acid, and in the reaction we still have the base, so they are going to react in a secondary reaction, and that's going to become a metal salt. Okay, so first of all, let's quickly have a look at what an ester looks like. So remember, we've got our double bond. We might have that as a carboxylic acid, so the carboxylic acid side, and then it's bonded to an alcohol, and in this case it's a methanol and an ethanoic acid that's reacted to become this ester, and this ester is called methyl ethanoate. Okay, so if we add an acid, we break it up by using an acid, what's going to happen is the acid's just going to split this bond again, and as it splits it, it goes back into the C double bond O OH that it used to be, and the other side goes back into the original state, and that's the alcohol. Right, so that's your two reactions, or the two solutions or groups that make up the ester. And with an acid called, like with hydrochloric acid or sulfuric acid, if we split it up, it just becomes, and it goes back to the two original states. And if we use a base, this is another story, because what's happening is it still goes into this acid and still goes into this alcohol, but remember the base, and if we use a base called sodium hydroxide, this sodium hydroxide, which is a base, is going to react with this acid, and then what's going to happen is you'll end up having something that looks like this. So you have a negative O, but then the Na goes and stands next to it. So this is going to be called sodium ethanoate. So that's your salt and your water that forms. And remember that H and that OH combined and it became H2O. Right, so the two different ways of breaking an ester is either with an acid and it goes back to its original state, or with a base and then it breaks it up into the acid and the alcohol, but this acid reacts to become a metal salt and water. So a metal salt forms and an alcohol forms when we hydrolyze an ester with a base. So this hydrolysis of an ester has real life applications, and one application for this breaking up of an ester is making soap. So normal esters or natural esters exist in animal and plant fat, like oils or the actual like lard. Anything oily contains esters, so that's kind of what makes it oily. So what happens, they are a special ester, and their esters look like this. So they're made from a tri-alcohol. Okay, so an alcohol that looks like this, and then a carboxylic acid, 3 carboxylic acids. Okay, so if we make up in whatever the chain is, and another one, and whatever. Okay, so when they combine, they add the ester bonds between those ones. Okay, so that's going to be a long ester. Okay, so if we look at this ester, it is a tri-ester because we've got 3 ester bonds between the alcohol. It's a triple alcohol or a tri-alcohol, and 3 carboxylic acids. So remember we looked at how if we break it up with an acid, what will happen is it will just split to become this alcohol, the tri-alcohols, and the 3 carboxylic acids. But when it's an animal ester or a plant ester, an oil, and we break it down with a base called, like with sodium hydroxide, what's going to happen is this salt, this metal salts that form on this side, will become the soap that we use. And we kind of apply this technique to everyday, or to make soaps today as well. So let's quickly have a look, and I'll just quickly draw this in a better way. So we've got our tri-ester, that's what we call this. So this is a molecule that's made up of 3 esters. Depending on how long this, we'll just pretend that this is the length of the chain. Okay, so we've got an ester, a tri-ester, because it's made up of 3 ester bonds. And when we add sodium hydroxide to that, remember what sodium hydroxide does is it splits the esters, plop, 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 right in the middle there. And then you have the alcohol, that each of those bonds will be an alcohol. Okay, we just draw it that way. Normally you would be able to draw it that way, so you can draw it this way as well if you want. Okay, so this and that is the same thing. It's just been switched around or drawn that way because that's the original way of drawing it. Okay, so we've got our tri-alcohol, which is all good, and then what we have is our 3 carboxylic acids that's separate, so it's not part of a molecule. This is a carboxylic acid, this one and that one. So let's quickly, so we're going to say 3 times, and what happens again, remember the O, double bonded O, and then the C, and next to the O is the sodium hydroxide's Na that forms. Okay, so we'll put that as plus NaOH. Right, so NaOH, and then we have this the 3 sodium ethanoate molecules that form based on the ester that's been broken up. Okay, been hydrolyzed, and this is called your soap. And this whole process of using natural esters and breaking them down with bases is called making soap. But the fancy word for making soap is called saponification. So saponification is the process where we use natural esters that occur in animal and plant oils. And what we do is we break them down with a base, and then it becomes soap, or a metal salt, and the metal salt is called our soap that we use. Could this be that